Okay, so let's solve quiz 2. So basically here we are looking at Miller index notation for directions and planes, and then we've got a problem discussing the lattice spacing. This first problem asks us to draw an arrow indicating the 3, 2, 1 direction. Well, that's just basically a vector, and we'll define our origin in this back corner. And 3, 2, 1, that's a vector outside of the unit cell, so it's a little bit tough to work with. So what we're going to do is we're going to divide by the largest number, 3 in this case, to get a vector that is scaled to within a single unit cell. So 3, 2, 1 divided by 1/3 gives us 1 2/3 1/3. So we're looking for a vector that moves 1 in the x direction, 2/3 in the y, and 1/3 in the z. And let me draw an arrow. This. Like that. The next problem is identify the Miller direction shown in the figure. So here we have an origin. To get to the tip of the vector, we have to go -1 on the y, or sorry, -1 on the x, +1 in the y, and plus 1/2 in the z. Now, in Miller index notation, we need to be working with integers, so we'll multiply by 2 to get -2 plus 2 plus 1, and then we're going to write that using the correct notation, which is going to be square brackets 2 bar 2 1 to specify the direction, where the bar is the negative. This problem is to identify the Miller plane drawn in the figure. So identifying the Miller planes, we look at the plane and we indicate where it intercepts the axis. So that is at 1, 1, and 1/2. So 1, 1, 1/2, and then we invert that to get 1 divided by 1 is 1, 1 divided by 1 is 1, and 1 divided by 1/2 is 2. So this is the 1, 1, 2 plane. And here we're supposed to draw the 1, 2, 2 Miller plane. So we have 1, 2, 2. We invert that, so we get 1 over 1 is 1, 1 over 2 is 1/2, 1 over 2 is 1/2, and this is going to be where we intercept the plane. So we intercept the x-plane at +1, the y-plane at 1/2, and the z-axis at 1/2. So we'll draw in that. Like that. And lastly, given we have a cubic unit cell with a given lattice parameter, what is the spacing between the 1, 1, 3 planes? So we're going to use the equation DHKL is equal to A over square root of h squared plus k squared plus l squared, and HKL is HKL equals that. So D113 is equal to 3.2 angstrom divided by square root of 1 squared plus 1 squared plus 3 squared square root is equal to 3.2 divided by square root of 11, which is equal to 0.96 angstrom, or 0.96 times 10 to the minus 10 meters. 0.96 times 10 to the minus 10 meters. And that is how to solve quiz 2.